Hello, in this video lecture I will show you how to data acquisition or using FTK imager by access data on Windows. Let's get started by opening FTK imager. Click yes, and top of the application bar click file and click create disk image. So you can see here we have several options about how to evidence type, store evidence type. So physical drive is a capturing entire hard disk drive, SSD or USB drives, which is if you have 8 gigabyte USB drive, the evidence file will be the same size of evidence device. So physical drive is copying entire drive. This includes deleted or fragments. The entire drive. This option is capturing entire hard disk drive. Logical drive is capturing a specific partitions. So if you have 500 gigabyte hard disk drive and there are two partitions, one is first is 200 gigabyte C partitions and second is 300 gigabyte D partitions. So C partition is system partition, D partition is backup partition, which you are uploading your placing here your games or movies or something. So if you click this logical drive and select what partition you need to use evidence and accuse, this partition will be accused. The other partitions is not touched. So if you want to accuse storage acquisition of 200 gigabyte hard disk, 200 gigabyte partitions of hard disk, this is what you want to use. Image file is capturing CD image or ISO file, contents of a folder, capturing contents of a folder, the specific path, or FMS to derive multiple CD and DVD capturing. Click on finish, and you can see here I have two hard disks. First is 32 gigabyte SCSI hard disk, which is in my system is installed on it, and second is 5 gigabyte hard disk drive, which is it is not a partition. This is a hard disk drive that created with virtual machine, virtual disk. This is the this two of these disks is virtual disk. So I'm going to show you how to create a virtual disk in VMware. So in order to create a virtual disk in virtual machine, you have to click on player options, the top left corner of the VMware player window, and click on manage, click on virtual machine settings. So you can see here we have two hard disk drives. The first is 5 gigabyte pre-allocated my device, and the second is 30 gigabyte system hard disk drive. This is of course virtual hard disk drive, and in order to add hard disk drive you have to click the top left bottom add button and select hard disk drive, then click next. You can select whatever you want, but SCSI is recommended, and then create a new virtual disk. Select a new virtual disk extension, and you can see here you have to type how many gigabyte you want to allocate for your new hard disk, virtual hard disk drive. And after typing your allocating memory, click allocate all disk space now, and click next and click finish. So now our virtual machine disks is creating. This might take several minutes depending on your how many gigabytes you typed. But if you're using the SSD, this will of course more fast. This so our creating process is created. So you can see here I have 5 GB unallocated disk space in my disk management file program. This shown here. So I will be use this as a test for the evidence. So let's select and let's select physical device drive and click next. So I will select 5 GB 5 GB newly created virtual disk for using, and you can see here adding destination. So I want to talk about what is these extensions about. The RAW format. The most used file format. RAW format is a bit-by-bit copy of the RAW data of the drive under investigation, and it can be used to image either the cupola drive or a single volume partition within it. RAW file format's main advantages lie in its ability to ignore minor read errors from the source drive, in addition to its fast data transfer. RAW format cannot store metadata within it. However, some applications store such metadata, hash value of the image file, drive serial number, etc. in a separate file. RAW format is supported by most computer forensic software, and it is the default file format for the output generated from the famous Linux Unix ddif command. RAW format has several naming scheme extensions such as 001, DD, DMG, RAV, and EMG. The main shortcoming of a RAW format is that it requires the same storage space as a source drive, because you cannot compress data when it is in RAW format, and this could be a problem when acquiring large hard drives. Smart. This file format is designed for Linux systems. So this format keeps the disk images as pure bit streams with an optional compressions. This file consists of standard 30-byte header followed by a series of sections. Each section includes its type string, a 64-bit offset to the next section, its 64-bit size, padding, and the CRC, in addition to actual data or commands, if applicable. AFF format. Advanced Forensics Format (AFF) is an open source, extensible file format for forensics images. Its source code can be freely integrated into other open source and proprietary programs. AFF supports two compression algorithms, zlib and LZMA. You can also split the resulting forensics image file into multiple files. AFF supports encryption of drive images, beginning by AFFV version 2.0, so you can protect your acquired image with a password. AFF allows wide arrays of metadata info to be stored within the image file itself. This should effectively reduce the hassle and allow for one file that stores all information related to acquired forensics image. A metadata file can contain the chain of evidence or a.trial. The latest version of AFF4, while AFF3 and AFFlib3 have been deprecated and should not be used for new project. The following computer forensic software supports newer versions of AFF: Sleuthkit, Autospy, Off-Mount, X-Mount, FTK Imager, and etc. A01. A01 file type is a forensic disk image file format, which is legally denoted by the Expert Witness Program (AWF). The file was introduced by InCase from Guidance Software. The major functionality of this software is to create an image file from the suspect hard drive, external media, storage media, etc. So I will select RAW DD images for my evidence file, and after selecting this evidence file, click next. So you can see here we have to type case number, evidence number, unique description. Case number is 001, evidence number, this similar case number. Unique description is description about your evidence or how it's getting, whose evidence is it. Examiner, your name or name and surname of examiner. Notes and notes about how can this have to be stored or something. So you have to select here image destination folder, which is if you are capturing your own C drive image, you have to place it somewhere hard disk drive or another partition of you capturing your C drive, which is this is not logically way to capture your own system drive. You have to plug out your hard disk drive and capture by another computer by plugging in. This is the best way to do it, to capture your entire hard disk drive. This is not a logic way. It's not the logic way to make your own drive, make your own evidence file using your computer hard disk drive, system hard disk. This is not possible. But this is possible, but not a logic way. So you can see here I'm typed my image file and selected the destination folder, and there is you can see image fragment size, which is 1500 megabyte is typed here automatically. But you can, if you want to don't fragmentation, you don't want to fragmentation on your evidence file, you can just type 0 to capture entire evidence, storage evidence without fragmentation. Click on finish and click on start. So you can see here our this image is creating. This depends on the hard disk drive speed, or if you are using SSD, this will more fast. So our fragment is downloading, extracting. So this verifying the hash values of my evidence file. So you can see here the image results is shown here, the MD5 hash, name of the images, sector counts, and computed hash, MD5 hash, which is a computed hash, and the report hash should be same. CHH1 hash, computed hash, and report hash is same. This is not problem. This is no problem here. Save this hashes somewhere to this will use when making after data acquisition. You have to verify that you are analyzing exact file without changing on it. We have mentioned it, how hashing algorithms works, how hashing is made, and this is the best way to do investigating it. And you can see here, this is an image summary about my evidence file. So our video lecture is end here. You can see here our images is here. If we click on properties, we have exactly bytes, how many bytes was my hard drive, the exact bytes of here that copied entire hard drive to evidence files. This can be investigated and analyzed for during these times. And